Here's the solution guide for the first derivative quiz study guide. Our first problem, let f be a function defined to be 4x cubed minus 5x plus 3. We have to find the equation of the tangent line to f at the point where x equals negative 1. Okay, so we're going to be using point-slope form, so that's y minus y1 equals m times x minus x1. We know that the given x1 is negative 1, so we can replace x1 with negative 1. Since we're subtracting negative 1, that means we're actually adding 1. Right? We need the corresponding y1, and we need the slope. The y1 can be found by taking the negative 1 and plugging it into the function. In other words, y1 is equal to f of x1, which is equal to f of negative 1, since x1 is negative 1, which will be 4 times negative 1 cubed minus 5 times negative 1 plus 3. Negative 1 cubed is negative 1, times 4 is negative 4. Negative 5 times negative 1 is positive, and then plus 3. So we have negative 4 plus 5, which is 1, plus 3 more, which is 4. So y1 is equal to 4. So over here, y minus 4. Now we need the slope. We need the slope of the tangent to the curve at a point, which means we need the derivative. So we need our f prime of x. We need to derive 4x cubed minus 5x plus 3. 4x cubed, we have to use our power rule there. 3 comes down, meets up with the 4. 3 times 4 is 12. And then we lose 1 in our exponent, so 12x squared. Minus, and the derivative of 5x is 5. And the derivative of 3 is 0. We don't need to write anything. We want to do the exact same thing that we did down here, which is plug our given x1 into the derivative in order to get our slope, because the derivative is the slope of the tangent to the curve at a point. Which point? X equals negative 1. So we plug negative 1 in for x. We see negative 1 squared, which is 1. 12 minus 5 gives us 7. So we now have y minus 4 equals 7 times x plus 1. That is in point-slope form. All of our answers are in slope-intercept form. So a little algebra to get our solution. We're going to distribute the 7. And when we do so, we have 7x plus 7. And we move the 4 over to the other side by adding it to both sides. So y equals 7x plus 11. And B is your solution. For problem number 2, what is the instantaneous rate of change at x equals 2 of f, if f is the quantity x squared minus 2 over x minus 1? Instantaneous rate of change. We know that this is another way of stating the derivative. So we're looking for the derivative of the function at x equals 2. So we have to derive this function, which means we have to use the quotient rule. So f prime of x equals, we have a fraction. We know our denominator is going to get squared, so we can fill that in right away. In the numerator, all right, it's bottom d top. So x minus 1, and then take the derivative of the top, and the derivative of x squared minus 2 is 2x. Minus, now top d bottom. So we keep x squared minus 2, and take the derivative of the denominator, and the derivative of x minus 1 is 1. You don't need to write it, I'll put it in there. But now we have bottom d top minus top d bottom all over bottom squared. So we need to find this derivative when x is equal to 2. We are asked for f prime of 2, so let's plug in 2. So we have 2 minus 1, we have 2 times 2, we have 2 squared minus 2, we have 1, and we have 2 minus 1 squared. So 2 minus 1 is 1, 2 times 2 is 4, 1 times 4 is 4, 2 squared is 4, minus 2 is 2, times 1 is still 2, so 4 minus 2 in the numerator. In the denominator, 2 minus 1 is 1, squared is 1, so we can see from our arithmetic that this will go to 2. Our answer is C. And finally on this page, let f be this piecewise defined function. Which of the following statements about f are true? Okay, well, the first statement says f has a limit as x approaches 2. That means the limit from the left must be equal to the limit from the right. So the limit as x approaches 2 from the left of the function means we're going to plug in values just a little bit less than 2 into our function. And if x is not equal to 2, we use this top function. So when we try plugging in 2 here, because it's easier to plug in 2 than 2.0001 or 1.999, when we plug in 2, we are looking at 0 over 0. So we're going to simplify the numerator, x minus 2 times x plus 2, just like we've done in previous classes. So now we can eliminate this, and we see that our function really behaves like x plus 2. So the limit, when we plug in 1.9999 now, it turns out to be 4. And not only that, when we plug in 2.0001, in other words, values of 2 as we approach from the right, we're also going to plug in basically 2, and 2 plus 2 is 4. So in both cases, the limit as x approaches 2 from the left and the right is equal to 4, so that is true. If the limit is equal to 4, right, because we know this is the limit as x approaches 2 now, since the left hand and the right hand are both the same, well, then we need the function to be equal to 4 as well in order for the function to be continuous. But we are told clearly right here that f of 2 is equal to 1. It's not 4, it's 1, and 1 does not equal 4, so therefore this one is false. Okay, we don't have the same value at the function as we do at the limit. And the only way, differentiability implies continuity. So in order for a function to be differentiable at x equals 2, well, it has to be continuous at x equals 2. Since the function is not continuous, it's definitely not differentiable as well, which means our answer is A, 1 only.